Welcome all to the online lecture series of Mechanical Engineering Materials. Today we'll be studying about steel and its alloy. It is a part of your unit number 2 and the course outcome for this is selecting a relevant ferrous materials for mechanical components. Now let's understand what are the unit outcomes. First, in this unit we'll be going through 5 unit outcomes. These are as follows. First one is to interpret the given equilibrium diagram. Then use the iron carbon equilibrium diagram for the given application, followed by identifying the given phase diagrams and reactions with justification. After that, identifying the given phase diagrams and reactions with justification, and finally selecting a relevant steel for given application with justification. Now let's look at what are the topic outcomes. Today in this lecture we'll be studying four main concepts. These are: first one is a phase of a metal or phase of a material. Next is what is pure metal, then alloy, and finally solid solution. Now let's start with our first topic, that is phase. So what is phase? Phase, it is a form of a material having characteristic structure properties. It is a form of material which has identifiable composition, structure, boundaries, separating it from the other phase in a material volume. So phase is nothing but a simple material which has some characteristic structure. It can be a metal, non-metal. It can be, example can be a gold, example can be sand, brick, a steel pipe, a raw steel, etc. So any material which has some sort of characteristic, identifiable characteristic. That means it should be have some sort of a luster, some sort of a color, some sort of pattern, some sort of appearance, composition that is different from others materials. So this type of a this form of a material having different characteristics, nothing but its phase. So if we want to take an example like water, in a liquid phase it's a water. When we heat it, it gets converted into a vaporized steam, and if we freeze it, then it's converted into an ice. So here water has three phases: solid, liquid, gas. In every phase it has different characteristic. In solid phase, it has the ice has a different characteristic than the water in a liquid phase, and finally the steam in a gaseous state has a different characteristic. So in this way a material has a various phases depending upon its characteristic and properties. Next, let's look at what is pure metal. So as we know, it is a substance that contains atom of only one type of metallic element. Here we can see there are different examples available to us. Like here, this is a copper, this is your zinc, and this is gold. So as you can see here, aluminum, copper, gold, iron, zinc, mercury, all these are example of a pure metal. These pure metal, when mixed with other pure metals, what we get out of it is nothing but an alloy, and which is having a different properties than the pure metals. Now the next term is alloy. So alloy is a mixture of two or more elements in which the main component is a metal. The first alloy made by human was a bronze. So we have all know the bronze. We have seen it in your Olympics, the where players are awarded with bronze medals. So this bronze is nothing but an alloy. What type of alloy it is, what are its properties, what are the main components, that we will study in later part of the unit. As of now, just remember the alloy is nothing but mixture of two or more elements. It can be two or more metals or metal or some other element. When we have the mixture of two or more elements or two or more metals, it results into an alloy. Most pure metals are either too soft, brittle, chemically reactive for the practical use. The best example for a pure metal having these sort of properties is gold. So gold is in its pure form, that we can call this as a 24 karat gold, which is a pure form of a gold. It is too soft, brittle, or chemically reactive for practical use. So when we say that we purchase a gold ornament or gold in pure form or gold ring, etc. Here the gold used is not a pure gold, it is a 22 karat gold. So it's a type of an alloy of a gold. So here the purpose of that is to make sure that the whatever the jewelry that we make from gold should be strong enough to sustain any damages. If we use the pure gold, it won't last for longer time, it will break or it will damage, because a pure gold is a soft, brittle and chemically reactive element. So as we discussed earlier, the main aim of making alloy is generally to make them less brittle, harder, resistance to corrosion, and have more desirable color and luster. So these are the main characteristics or main reasons behind making an alloy of any element, alloy of any metal. Of all the metallic alloys in use today, alloys of iron, that are steel, stainless steel, cast iron, tool steel, alloy steel. We will look all these type of alloys of steel in detail. Further, to make up the largest production both by quantity and commercially. So steel is the best example of alloy, or rather the most commonly used, most commonly produced type of an alloy. It is an alloy of what that we will look when we specifically go into different types of steel. As of now, just remember, when you talk about steel, it is an alloy of iron, and iron itself is a pure metal. Now let's look at a last point, a small point. We know when we talk about solution, we always think of a liquid solution, but today we'll be considering about a solid solution. It is nothing but a uniform mixture of substances in a solid form. So here when you say solid solution, the solution is in a solid form, not in a liquid form. So what's the difference? Let's see. Solid solution often consists of two or more types of atoms or molecules that share a crystal lattice, as in certain metal alloys. Solid solution are two types. So the crystal lattice we already discussed. We have seen what crystal lattice is, how crystal lattice is formed. So we know that crystal lattice is nothing but a geometrical arrangement of a unit cells, and unit cell is nothing but an arrangement of atoms at a corner of a cube. In a simple word, it is nothing but a smallest unit of an material, smallest unit of an element. Okay. Now let's look at the first type of solid solution, that is substitutional solid solution. Okay, so the word substitute is nothing but when you remove one element or one part and replace it with the another part. That word, or that the meaning of word substitute is nothing but replacing one with another. So as you can see in this example, this is substitutional solid. Here you can see solvent metal atom and solute metal atom. So solvent is nothing but your basic metal atom, and solute is nothing but your minor metal, or this is a major metal, or this is a minor metal. So what happens here, the atoms or solute, that is this green color atom shown by green color, are replaced by or substituted by the solute atom. Okay, so here you can see the solvent has a more number of atoms than that of a solute. So solvent is a major element or major percentage element, this is a minor percentage element, or the element with less composition. So if the, let's see, look at into detail. If the atom of a solvent and metal and solute are of similar sizes, not more than 50% difference, they form a substitute solid solution where part of solvent atoms, this is a key point, where the part of solvent atoms are substituted by the atoms of alloying element. Okay, you can see here part of solvent is replaced by your solute. Okay, now the next type is a interstitial solution or interstitial solid solution. Now first let's look at this picture. You can see here the solute, let's say the solvent is the same type of element as it is used in substitution solid. This is the solvent element, here we are also using, let's say, same element. Now you can see the solute here has the size very much smaller than the solvent metal. So in this case replacement is not a option. But what happens, this solute element gets placed or gets trapped within the space available between the two adjacent solvent metal, two adjacent solvent metals. Okay, if atom of alloying elements are considered smaller, as we can see, this is the alloying element, this is your base element, then the atoms of the matrix metal institutional solid solution forms where the matrix solute atoms are located in space between the large solvent atom. So the difference here is that in substitutional solid solution, both solvent and solute had the same size atoms. In interstitial solid solution, the solvent and solute has a different size. Majorly, the solute has a size very much smaller than that of a solvent atom. That's why the solute gets arranged or gets fitted into the spaces between the two adjacent solvent metal. Steel used in construction, for example, is a solid solution of iron and carbon. So as we have discussed earlier, the steel is the most commonly used alloy, and it is a mixture of what? Iron and carbon. This we will be looking thoroughly and in detail about this iron carbon diagram, or how steel composition, what are the steel different steel composition available, what are different metals having iron carbon composition, we will discuss in next video lecture in iron carbon diagram. But as of now, just remember, when we talk about solid solution, there are mainly two types. One is a substitutional solid solution where solvent atom or base metal atom and the alloying element or alloying atom are of same size, and the solute element replaces the atom of solvent. The composition of solvent is higher than that of solute. While in interstitial solid solution, the solvent atom is a pretty larger in size than the solute element. That's why the solute element gets fitted inside the solvent atoms spaces. Now let's look at the practice question. Which of the following is an alloy? Silver, gallium, 24 karat gold and 22 karat gold. So we have discussed this while discussing about pure metal, that 24 karat gold is a pure form of element. Similarly, silver is a pure element, gallium is also an pure element. So remaining is a 22 karat gold, and we have discussed that to make gold more harder, more stronger or less brittle, 22 karat gold is used because it is an alloy of gold. Next is, which of the following is not a pure metal? Okay, iron, zinc, mercury, brass. So we all know that iron is definitely not an option. Zinc is also pure element, iron is pure element, zinc is pure element, and so is a mercury. We have seen mercury in your thermometers. So the next option is a brass. Now you guys have a homework to find out. It's a simple homework, you just have to search it on Google. What is the alloying elements for brass, and other is what are the alloying elements for your 22 karat gold. Thank you everyone. I hope you have understood all the points that have been discussed in this video lecture. In next lecture, we will discuss in detail about iron carbon diagram. Thank you.